All right, hello everybody, thanks for coming. We are Proporeception Studios. I'm Michael Beza.
I'm William Wynn. I'm Kyle Lee.
And I'm Stephen Garber. And we're here to talk about our product, which is streamlining the implementation of muscle simulation for use on skin deformation, or in other words, the My Muscle Toolkit. What we're going to be talking about is a problem statement, hypothesis, research question, elevator statement, give you a demonstration of our product, a little bit of research, and the conclusion. So to start off, what is the problem? The current solution for simulating muscle deformation in commercial animation software is too expensive for small budgets. Now, when you want to show muscle deformation in your character, you don't always need to, but the current solutions are very long. It's a very long process, and you still might not get the best results with it. Another problem is a lot of big house animation companies have their own software to show muscle simulation and deformation in the characters, but this could be too pricey to obtain. So that's a problem we're facing. Like, what can we do to help people like students or small companies help show muscle simulation in their characters if they need it? Our hypothesis: a series of pipeline tools integrating the process of skeleton generation and muscle placement can simplify the implementation of muscle simulation in a rig, as a result reducing the barriers of entry, such as time and inexperience, by pinpointing the core of a working muscle simulation. This will allow for freedom of self-exploration and learning. So basically, we want to create a tool that will cut on hours of production. In this case, we're going to be using Maya Muscle within Maya 2013. A problem with Maya Muscle, though, is even if you know how to use it, it's still a very long process. You still have to place each individual muscle into the body of your rig. So basically, we know, if you can cut on hours of doing this, like rigging, putting the muscles in, you can save time for more areas of the production pipeline, like animation or compositing, the final stuff. So this leads to our research question: how can we simplify the process of muscle simulation in a small group animation pipeline? So basically, how can we take a software that's readily available to everybody, such as Maya 2013, anybody can get a hold of Maya, and use the tool Maya Muscle to basically save time and money and speed up the process. And this is our elevator statement. For students and small studios who wish to incorporate muscle simulation in their rigs, a series of pipeline tools will increase the time efficiency of an animation pipeline. The Muscle Toolkit takes advantage of current existing software solutions to streamline the process. So that's what we wanted to do from the beginning, was make a tool that can save you time, save you money, and help you out in the long run, and basically streamline the process. All right, now I'm going to hand it over to Stephen, who will basically show you our product.
Before we proceed any further, we're throwing a lot of big terms at you, so I felt like it's best if I refer to some of the key terminology in case you aren't familiar. There's a handout. If you have one of the handouts, just follow along. I'm not going to go too in-depth, but like we said before, we're focusing on Autodesk Maya 2013. That's the application that we're familiar with. That's what we've been taught. And we wanted to more focus on the muscle deformation, or the muscle simulation side of things. So we didn't want to venture too far from that. Next would be character rigging. Character rigging is the process of getting a character ready for animation. Moving down to Maya Muscle is the tool that we're going to be focusing on, which I'll get into more detail shortly. Meshes, series of vertices, edges, and faces make up a character model. I mean, I guess in this case it's a character model. I mean, it can be an environment. Think of like anything in 3D space, and then think of how you convert that into something for digital. And so a polygon mesh would be what you do in that case. Pipeline is just the process by which an animation is developed. Moving down simulation, after a process of pretending. Skin deformation is the process of deforming a character or making them move, animate. Weighting is how you distribute the weights on a character so that you have streamlined deformation. Now, when you look at the human body, there's a lot of muscles, there's a lot of ground to cover. How do you simulate this in a human character? And if you also look at a character rig, it doesn't really have a solution for muscle on it. It's just a series of joints that deform or rotate, essentially, in different directions. And while people have very clever methods of controlling and deforming these rigs, they still only bend at one point. So how do you solve a problem involving like keeping shape and also causing bulging and maybe jiggle depending on the size of the character and their mass? You can't really do that with just a normal rig setup. You need something entirely different. And this is the problem that we're trying to solve in our research project. So potential solutions that we considered were as follows: blend shape, cloth simulation, influence objects, joints, and mind muscle, which I'll go in more detail on all of these in the following slides. So the first of these would be blend shapes. Now these are essentially target points that a mesh would deform towards or interpolate between as the start and end point. So you have your initial mesh, and then these, for example, people tend to use these more for facial animation because you're only going to certain target points, so you don't have to worry about them interacting between each other. And these are based on level of influence or level of rendering influence. So they go down a stack. So they don't really interact with each other. They just kind of displace things, and then Maya looks through it and says, okay, I need to displace based off of how far that they decide to use this blend shape, and then they also decide to use some of this blend shape. So it's going to deform even farther. It's just going to add on the displacement value, essentially, of each individual vertex. And so since they're not really interacting with each other, we can't really get an accurate muscle simulation with that. And while it was probably an easier method of muscle simulation, we just weren't getting the results that we wanted. We wanted something that more interacts with the animation. Another idea would have been to use a cloth simulation, because cloth in Maya does interact with animation, and while this actually can achieve really good results, cloth in Maya is a beast to handle. I mean, they worked on this in their other class, 540, and the whole class is freaking out about it because they're trying to get the cloth to deform appropriately around their character. And so we can't really afford people can't really afford the time to fine-tune a cloth simulation to cover an entire muscle system that you also have to model underneath the character. So we decided that this probably wasn't the best method either. Just simply due to the number of settings, as you can see on the right on the screen. There's a lot of different settings, and it scrolls down too, so I mean there's a lot more of these drop-down windows. This was too much of us. We wanted to avoid this. And so we looked at something a little more simplified, similar to blend shapes would be influence objects. Influence objects are just simply things that will change shape depending on the rotation. You can drive it with the rotations of the joints or based off of the movement. But it still really isn't a real simulation because it's just running between endpoints, and it still doesn't interact with other ones around it unless you program it to. And the amount of scripting involved with that wouldn't even make it worth it. Another solution for where I actually talk about my muscle though would be the joints-based system, where actually a series of joints will rotate based off of the movement of the arms and relative to each other. And this is a much more involved process. This would probably be the most complex method of muscle simulation, and probably could achieve the best results. But the amount of programming that it would take would just be so unrealistic that it would never be foreseeable for an animation pipeline. Even if you had a streamlined tool to go through it, it's still so complex that if you ever need to fine-tune something, it wouldn't be worth it. So that brings us to our final solution idea, was My Muscle. These are a series of tools that were released in Maya 2009, and they're intended to simplify the process of muscle simulation, but they're still very complex in their own right. And so when we decided to choose this option, we decided that since this was it provided the most options, it was a real simulation, and it kind of took the best of influence objects and cloth simulation in its own unique way, and had a lot of different settings, and we felt like we could use this to best create our tools inside of Maya. Okay, so now I'm going to actually go into a live demo before we actually go into our pre-production and show you more of what we have done, just to kind of give you an idea of how our product works. As you can see on the screen, I've got our character, and where'd the mouse go? I guess I don't really need to use the mouse. And now we have it set up so that it's pretty easy. If you roll over this little button, it should actually show you the script briefly. It goes down for, well actually this is just a Python script, so it's not that one. But this will load up the other series of scripts which we use to use our pipeline tools. And so how the script works is it just gives the user a series of directions that they need to follow in order to place the muscle on the character. I probably should use this mouse, but And as you can see, they're not quite matching the character. This is a problem that we had to do with, that we wanted to solve, is that we want to make this work for any biped character. So what we did is we actually made the rig scalable, since this is an auto rig, and then we also made it, it's really hard to see since I can't zoom in. But I mean, all the locators are movable. It's really hard to see on that screen. Oh. Oh, is it already hooked in? Why was it moving? Okay, sorry about that technical difficulty. Going through here, I can place these wherever I want, and it will create the skeleton as follows, which the skeleton is completely reliant on, or the muscle tools are actually completely reliant on muscle rig, or on the outer rig system. I'm not going to go into too much detail on this. It's not necessarily necessary for this demo. Just kind of showing some of the functionality of it. I can totally break things too. And it will still, the muscles, when I actually go in and place them, will actually calculate based off of the length of the joints. So they're not just static shapes. They are based off of the size. So if this character was larger and I scaled it up, the problem of scaling of the muscles has been solved. Actually, I could even show that. I'll just global scale this even more. And then we also have the placement for the controllers. Actually, oh yeah, joints, control scale. Should put those on their own layers, so I don't have to worry about selecting them. I can scale them all at once. I can scale them individually. That's not a problem. But these are just the controllers, so I'm not going to worry too much about them. I'm going to move on to the controllers. This should mirror all the controllers in place, and then I'll actually move on to the meat of the project. I'm going to go ahead and bind it and then convert it to a muscle system, which it's doing for me. This is one of the major. Actually, this is actually a really simple process, but we didn't want to confuse people. We just wanted to make them have just the buttons on the screen, so that we'll take them through the whole process of our muscle rig system through these series of tools. It has the default weights painted on it based off of the dual quaternion skin bind, so it'll try and convert those the best it can to muscle weights, but it's best to just go back and paint those weights yourself, because they won't be the best. That. Creating the muscle, we'll then go ahead and place the muscle on the screen. I'll actually zoom in a little bit so you can see it better. This is the meat of our project right here. This is what this is all about, is getting the basic muscle system set up for the user to use, and just getting everything placed on the screen. It goes through, calculates, determines where they need to be placed, positions them, scales them as appropriate, and just goes through it all. Now this is where the most of our waiting time for the actual thing is, depending on the speed of your computer. Just waiting for it to make all these calculations for you. And then say you want to change a muscle, but you don't want to actually change it after it's been created or bound to the mesh. You can actually go in and you can say, okay, oops, I don't like this muscle. I don't like it and I want to remake it. So then it will go before it finalized. It'll delete the one on the right side. Then you can go ahead and make whatever changes you want. I really don't like the shape of this pod, so I'm just going to make it go. Let's see, just select the locator. That's all. No. I want to make it farther back. I don't like this. I want it more like that. Then I can go in and be like, okay, that's better. That's more how I want it. So now I'm just going to mirror it. And convert to muscle. Okay. Actually, I had it not. And then it's going to try mirroring it the best it can. And then once I'm finished with this, and I'm just like, okay, that's good, I'm going to bind it to the mesh. And this will now take all of the muscles that you've created and are connected to the muscle system and bind them so that they have influence vertices on top of the mesh, that you can actually paint the influence of these muscles when they deform on the mesh. Now this whole process takes about a minute, so I'm going to actually skip through it. No reason to do it. I'm going to try and do all these individually actually. Anyway, you can go ahead and wait for this to finish. I suppose it won't take too long. But once this is finished, I'm actually going to hit close. It's going to pop up a window that says paint muscle weights, and you just then paint on the weights on top of the mesh. And that would be how you paint your influence. I'm actually going to show a finalized tech demo of all of the weights painted. It just shows some of the animations of what the deformation will look like. And still going. This is when we did our testing. This was actually where the bulk of our time came from. Was on the testing, was waiting for this to finish. This was a lot of settings. There we go. That's the last two. And when it closes, it will pull up the muscle paint tool for the user. Actually, go on back to the slideshow. And then just to show real quick of what our finalized looks like. Screen. Sorry, there's no audio. But this is just what it looks like when you're animating it. Just showing a few different things. It's really dark screen, but you can just see that it's deforming the mesh around the muscles where we painted it. So we wanted to let the biceps push out more, so we painted on there. And as you can see, it's deforming the actual mesh. These are the finalized renders. We have video of the arm, abdomen, chest, and then we also have a run cycle at the end. These just real quick. It's really hard to see on this one, but you can see like the contour of the muscles pushing out on the sides. This is just a series of squats, just to show the legs, and the jiggle effect if you look at the top of the screen. And then this was the finalized run cycle. It loops through 3 times. But that was our tech demo. And now William will talk to you a little more about our pre-production.
Alright, so this is our Gantt chart showing about basically what we've kind of planned throughout the semester, from where we were going to go from go, no go, where we got our go to continue on with our progress and everything like that. So basically a breakdown of some of the process that we did though for the Gantt chart. Essentially the main ones were we created models, we had to texture them, light the scenes for the models as well, create an auto rig script, learn about the myo muscle ourselves. Then we had to create the muscle scripts, and then we had to combine them together. So here's some images of basically our models that we had to do. We had to redo some of the arms so that way you can see more deformation with the muscles, giving them more of a defining biceps or triceps or anything like that. So we had to go and redo those a couple times and stuff like that. This is some of the script for the auto rig essentially, where we had a lot of issues where it came to constraining and creating the controllers and everything like that, and placing them where they actually need to be and doing what they need to do and having it affect what it has to affect. Here's the muscle script, and that's we did this in Mel. Essentially, because we're using a lot of the MIS command lines, so we're like, we might as well stick with Mel for this one. And we had to use the Mel library where they had a bunch of the muscles. So we had a lot of issues with the painting the weights and figuring that out. And then the capsules, creating it where we needed it to be, caused some issues as well. Here's a short piece for just the biceps of creating the muscle that Stephen showed earlier. For just the biceps of bending the arms and creating it. And this is us when we combined it all together. This is how it looked like. We had the controllers there, which drove the muscles as well. And so in the end, our end product was we had a rig with a muscle to do the deformation for us. So Kyle will go over the results.
All right, for our testing, originally what we wanted to do was have our participants attempt to make a fully rigged character without our script, and then have them later on do it with our script and see the time difference. Unfortunately, if anyone's ever tried to rig a character, it takes a long time, and we didn't want to make our participants wait or have to like sit and work through that for such a long time. So our statistics advisor said that we should instead just give our participants our script with the knowledge that in general it's accepted that it would take a long time to do what we're having to do otherwise. So we wanted to just get a general idea of what the how much time it would take to run through our script on Zoom. So then, as for the actual testing itself, we gave our participants a pre-test where they answered several questions, just demographics like what's their experience in Maya, character rigging, stuff like that. Then we gave them our plugin. You saw the little interface on the screen with the steps that they had to follow. And then after they were finished, we gave them a post-test, asking them about what they thought about our product, stuff like that. Here's some of our demographics. As you can see here, many of our users had at least some experience with Maya. Unfortunately, only about a little more than a third had any character rigging experience at all. And another big problem we had was only 19% of our participants had any experience at all with muscle simulation, and only 2 of our testers had any experience with Maya muscle before. They really only just opened it up. So we have to kind of keep that in mind when we discuss our results. Our testers were not exactly the demographic we were looking for. Despite this, we found that our users thought our product skewed towards easy to use and pretty efficient. As you can see in these 2 graphs. And all of our participants managed to finish all the steps in 20 minutes or less. So I think that's pretty good. Our conclusions, because of our demographics not being exactly what we wanted, we can't really say too much about how well our product works, but we still managed to get everyone less than several hours that it would normally take. So we're considering it a tentative success. As for the future, we're planning on putting this script online so we can get a wider base of users. So everyone can download it for free, test it out, see what they think about it, give us feedback. As for legacy, one thing another group could do later on is we never got a chance to work on how the paint weights would affect our script. As it is, you have to paint all the weights yourself after you're done with our script. What would be nice in the future is if someone would work to automate this process where it would automatically weight your joints and your muscles for you, so you could at least have something a little closer to where you want it to be. You can go back and make fine-tune adjustments. I'd like to thank Professor Hassan, he was our sponsor on process, Professor Burton, our 411, 450, Professor Jeffrey Ting was our statistics guy, and several others, Eric Bao, Jenna Day, Tim McGraw, Dale Jackson, Jaime Camarillo, and Robin Lind, who we were in contact with by email for most of the semester. They helped us out a lot too. And with that, we're going to open the floor for questions.
Does the university let you put that kind of stuff out online? I know you're talking about your legacy, you're going to make that available for more people to test. Does the university have rules against that, or is there a process that you have to go through?
I believe for this, for our 411 for 50 as a senior project, there were some restrictions, but they've changed it recently in a way that the intellectual property is sort of ours as well, so we have the ability to actually put it up online. We have that freedom to do it.
Burton did inform us that it was still a little murky, but he said that he was pretty confident that we would have ownership of this product.
So if you're putting it, you're just putting the plugin online, you're not open sourcing it for other people to improve upon it, right?
I might
we
put it on
discussed
GitHub
that.
so that it would be, but we have.
We probably would want to aim more for open source if we're able to, just because we want people to edit it and update it too as well.
Okay.
But for right now, it's probably just going to be online for people to test, just so we can get some input. I was actually considering myself just continuing to work on this over the summer. I've really begun to like this project a lot. It's come a long way. It's kind of daunting at the beginning of the semester, but we feel like it's a really good portfolio piece for us, and we're really proud of what we've done.
What's paint weights? I don't know.
Pinning weights would be where you're essentially telling the influence that a joint or muscle would have on a particular vertex on mesh. So you just be like, okay, so I want this joint to have, like when this joint rotates, I want this vertex to go with it 50% of the way, but I also want it to stay where it's at 50%. Like, so if you had
Is
to
it
wait.
a proportional relationship based on movement?
Yes, it's based off of the rotation. So like, it's like it's parented to like the joint, but it's only 50% parented if you only paint it 50% of the way.
Okay, so that's a manual process.
That's typically a
Should be
manual
automated.
process. The problem that we face with the muscle paint weights is that it's not the same as the normal skinning paint weights, and we can't edit them inside of the component editor to our knowledge yet. If we can find a way to access those numbers, we can try and figure out a way to position it based off of the location and size of the model. But this is a much more involved process than we initially perceived.
Did you have a contact at Maya or Autodesk?
We do have a contact at Autodesk. When we went to GDC, we actually talked about a product with an Autodesk employee, and he wanted us to inform him at the end of the semester when it's finished, because he wanted to also test it.
Yes.
Approximately how much time do you think someone would save if they were to use your plugin instead of doing it on their own?
Okay, well, creating an auto rig itself is about probably, depending on how good you are, around 3 hours. And then the other one for creating the muscles and placing them is probably about another, probably 6 hours to that. So that's around 9 hours right off that. And then painting the weights is another like, that one can take forever.
Yeah, that
So
one takes forever.
that one can vary from like 6 hours to even more than that. But essentially, they're saving probably about 15 hours of work.
So you're saying without this product it would take 15 hours, but with your product it would take 20 minutes?
Yeah, assuming that you didn't have any other pipeline tools, you didn't have an auto rig already, you had to make a rig manually if you needed to place the muscles manually. I wouldn't say 15 hours, I would say more like closer to 10, but yes, it would save quite a lot of time, especially if you don't know how to do any of this yet and you just want to worry about positioning the muscles and shaping them to how you want. Yeah, it would save around 10 hours.
Well, I mean, learning my muscle itself, it really depends. If you already know what it is, then yeah, it'll be a lot faster for you. But if you don't, and if you don't know anything about the human body, then you have to keep doing research on it. And most likely they don't, and so that's going to accumulate the hours.
The problem is that in-house studios don't have this, or I mean, small studios and students don't have access to this kind of scripting. So larger animation studios already have solutions to these problems. They already have their workarounds, their tools. So that's why we're focusing more on the public domain, because we want to create solutions for the small studios, for the students who can't afford it, but they still want to try and do muscle simulation or learn it. And they're just too afraid to because they don't know if they have the time.
How much would like a similar plugin, like a professional, like I'm not saying yours isn't professional or anything, but you know, like one that companies buy, how much would that be, like a monetary value typically?
Our product?
Like ones that other companies would buy.
To ours. We were looking online to try and find something similar. We weren't able to see anything that you could buy. Most studios tend to hold on to this stuff because this is their
Intellectual property.
Yeah, intellectual property. I mean, that's their stuff. They don't want other people to have it because they don't want someone to make something as awesome as theirs.
Maybe you can like consider selling it to other companies or like marketing it a little bit.
I mean, we considered it at the beginning of the semester, but we more wanted to focus on like the lower end, like the public domain. We wanted to make sure that like everybody has access to this kind of software.
We figured that since all the high-end companies already have their own product, there's really no point of actually like kind of selling it per se. I mean, it was more for, okay, we have these low-income industries and they're trying to, you know, make money off themselves, and we have a product that, you know, can help them with, you know, making things a lot easier and simpler, I guess you could say. And so, you know, here you go, the type of deal, instead of, oh, you can't compete against these guys because you don't have like a a huge team of like programmers programming something for itself.
So is it good for education?
Yes, I would say if you were just to take our script and run it and learn about painting weights and learning about the muscles, yes.
Yeah, so you're dealing more with the art than technology, is that what it's?
Yeah, we were taking care of more of the technology side, especially with the rigging process. A lot of like animators might not have a rig, know how to rig, but they want to animate and they want to animate muscle simulation.
Sure.
Then this can allow them to go through the process of placing all this, and then they can just worry about placing the muscles how they want them to look. And they can just get that to look all fancy for themselves, and they don't want to worry about making the rig or writing expressions. They don't want to deal with that.
Sure. So does this drive Maya ability further down in our program? So someone in the, what is it, 241, is that the first course?
Yes.
So do you use Maya in 241?
Yes.
Did you even contemplate doing muscle in 241?
No.
No.
Could you now?
Yes,
Yes.
and no at the same time. It's hard to say. It's as I can tell right now with the 241 students, they're struggling with creating an auto rig itself. So
Not rig, but they're struggling to
or
create a
they're
rig.
actually creating a rig. Yeah, they're just
Right,
struggling to
right.
create a rig itself for one character. So I mean, yes, I would love to give them this, and be like, here, use this instead. However, they also have to kind of learn how to create it, so then when they use it, they know why it's being done that way.
Yeah, they need a deeper understanding of Maya and how it's working before they could really begin understanding this. This would be more applicable in like classes like 341, 442, where they typically don't do muscle simulation or too advanced rigging because they're more worried about getting their animation finished.
So did I just hear that there's an emphasis on learning the software versus learning best practice in the art? Is that what we're talking about?
There's a necessary level of understanding of the software, or at least a similar interface, not necessarily just Maya, but just understanding 3D modeling software or 3D animation
Can
software.
I answer that question?
Sure.
I mean, since I do teach at
Sure.
241,
Yeah, okay.
I put an emphasis on both, actually. There is an emphasis on learning the software, sure. There's an emphasis on learning all of the concepts that underlie the use of the software and the art itself. But 241 is 10 pounds of stuff in a 5-pound bag, or maybe a 2-pound bag.
So what I'm trying to understand is, does the elegance of the evolution of the software impact the type of learning required to be successful in that profession? That's what I'm wrestling with. Because if you look at the history of all software as it evolves, and it becomes easier and better to do certain things, it tends to go to the definition of what's good based on some other expression rather than whether they can do it. So that's what I'm trying to understand, is this typical of the Mel scripting in Maya to develop a unique tool set or a general tool set that everybody begins to latch onto, which eventually the software becomes very easy to use instead of very complex. Still robust, but you can just do practically anything. That's what's going on.
The idea of creating a script for Maya essentially is it's kind of to speed along the process of how you do things, like creating a model or anything like that, simulating muscle per se, or creating a rig. It's to take those X amount of hours that you originally spent and kind of condense it so that you can do more for less, essentially.
Yeah, rather than wrestling with the software, yeah.
And usually the people who write this kind of software are the people who know how to do this anyway.
Yeah.
So they need to know how to do it well to create a rig that does it for you.
See, and that's what I'm saying, so we're really not lessening the student's responsibility to learn how to script.
No.
That's what I wanted to know. Good.
Terry, what they're doing, they're vertically integrating Maya to a specific point. I mean, that's exactly what I do with Max, and that's exactly why we have these scripting abilities.
So the assumption of the process is innate in, the job skill or the knowledge required to obtain a job.
Yeah.
It's not specific to the evolution of the software.
No.
Right.
No, think of it like Maya's like buying a suit off the rack, and now they're tailoring it for themselves.
Sure.
That's exactly what they're doing.
So that customization activity, which is what you've engaged in, is a very important process for all of us,
Yes.
right? That's all. I just want to make sure that's intact.
Yeah, because we just wanted to make sure that we were maintaining the creative freedom, but still pushing the process.
Well, yeah, once you understand the process, you should be able to create tools to shorten it, right? That's process analysis, I think it's important.
Do you like see this being implemented in any of the higher animation classes? And do you think it would help out the department at all?
I mean, it depends if Ray would let other groups use it or not. I mean, I don't know, because like learning how to rig is part of the learning process. It'd really be up to whoever's in charge of the curriculum.
And the fact that, I mean, for our rig right now that we have, you have to have a biped person, you have to have it like symmetrical. It won't work so that you can't have a symmetrical character.
You can make it work for a symmetrical character. You just have to do fine adjustments after it's created the muscle. So like after it's mirrored it. But yeah, it's for bipeds. There have to be a new script made for quadrupeds or any other amount of limbs, essentially. But that'd be another thing that'd be interesting to tackle in a future semester, or just on our own, see if we can solve that issue.
Who should have your test sample been if it wasn't those students? Because you saw a great diversity of ability, and I think in your bar charts there, that you, the ones that were completing it faster, the association logic would be, those are the ones that had more experience with the software.
Actually, it was quite the opposite. Those who didn't really know the software just kind of like mushed their way through it, and then they were done real fast.
So
didn't really know what they were doing.
So procedurally, they were able to get a finished product for, within the confines of your experiment faster than those that knew it.
It was a little bit skewed though, because people who were more experienced were actually playing with it and trying to break it and see what the different limitations were, and they were trying to spend more time with it.
Yeah.
So they're actually
That's
getting more
really
involved.
interesting. So they were trying to make you look bad.
I wouldn't say
Terry was
that.
doing.
I mean, I actually like that, like how they try to figure out what can break, because once they figured out what broke, we could go in and fix it. So things that we couldn't think of ourselves, and someone else comes up with, oh, this is, I can do this and it'll break. Well, we didn't think of that, someone actually trying to do that,
Okay.
and we
Okay,
could
so,
go in there and.
so I guess I didn't quite understand your experiment.
Key part of our testing was like our questions were oriented around figuring out what people didn't like and what they did like, and then what they thought was broken.
So you were encouraging the breaking.
Yes.
Yes.
Yeah, so the people that didn't, I understand.
So because we want to refine the product where, as much as if we were to send it out and, put it online for someone else to use, you can try as really hard as they can, but they can't really break it as easily, then we hit our goal. I mean, if we were, on our first testing day, we put it out there, it broke a lot, actually, and the second day of testing, we fixed a chunk of it, and they didn't break as much.
Actually, we fixed it within like the first 2 hours. I actually threw out the original testers for that part. But the first 2 hours was really broken. I almost suggested that they come back and test it again, but there had been no way we could have guaranteed they would all come back.
Yeah.
But yeah, it was much better after we fixed those problems.
So how'd you like the game developers conference?
It was awesome.
Oh, it was awesome.
Just two of you go?
Yeah.
Yeah, because we had
Didn't you go?
I'm on the advisory board, I thought that's right.
Yeah, I thought so.
So no. I live in EDC, Terry, trust me, I get about 3 weeks off and it all starts all over again.
I thought he was there, I was just like, oh, anyway, did you see that? You see that?
I don't think so.
There's 19,000 people there.
Yeah.
What did you tell me?
Well, yeah, okay, so I met Jack, but that was a that was.
Yeah, he sits down at one of the plenary sessions and one of our graduates sits right next to him.
Graduate I've never met before.
Anyway, I thought maybe you were having a little serendipity